Hello, summarizing a paper, Language Models are Supervised Multitask Learners by Redford et al. So, going through their abstract, the first point, which is very important and is the summary of all the paper basically, is that the natural language processing tasks such as question answering, machine translation, reading comprehension, and summarizations are typically approached with supervised learning on task specific datasets. We demonstrate that language models begin to learn these tasks without any explicit supervision when trained on a new dataset of millions of web pages called web text. So, this paper is basically about GPT version 2. GPT version 1 was already out, and in that version, they have said that after pre training a model on a large corpus of data, once you fine tune it on a specific task like question answering, machine translation, reading comprehension, summarization, etc., you get good performance from the model. In GPT version 2, the whole idea is to remove the step of fine tuning and see that in a zero shot environment, when a model is trained on a large data set, it should be able to multitask, do all these tasks by itself. So the capacity of the language model is essential to the success of zero task transfer. That's what they're saying. And increasing it improves the performance in a log linear fashion across tasks. And the largest model, GPT-2 1.5 billion parameter transformer, achieves state-of-the-art results in 7 out of 8 tested language modeling datasets in a zero-shot settings. Again, I'm repeating, zero-shot means it was not fine-tuned for any specific task, but based on the language nuances that it has learned through pre-training, it was directly asked to perform certain tasks. So this is called zero-shot. And then it was evaluated how well is it performing against the state of the art. Well, so NLP training for multitasking at the point of writing this paper was not a big thing, and the whatever current ML applications that they have studied were hinting towards that a specific general tasking mechanism was not there. There were like many supervised approaches where a singular task model has been trained and they were performing quite good. So the current ML system needs hundred to thousands of examples to induce functions which generalize well. So that was not existent, and therefore the motivation for this paper. And the approach that they have been leveraging on is that so any sentence or a text is sequence ordering. Sequence ordering means that every word that comes afterwards is somehow dependent on the list of words that have come before it. And that's what this formula covers, that if you're looking for the nth symbol, it is dependent on all the previous n symbols. And there are words where people said that you don't have to look for all the previous symbols. A few previous symbols should also be sufficient enough to approximately guess which word should be coming next. And this is the idea behind GPT, that auto-regressive nature. So this lies as a basic principle in all their papers. So generalizing it, they are like that you should be able to get the output based on certain input words that are already there. And one more variation to it is that when you have trained a very large model, as they're talking about, if you provide a task as well to it, it should be able to do the task that you are requesting it for. And McKenna then also suggested that since language in itself very explanatory, so if you train any model with the examples like translate to French, English text, and French text, and answer the question, document, and then you ask the question, and provide the answer. So if you are training on like such kind of data sets, then a model can actually start doing multiple tasks that you have shown through the examples. And this becomes a very good motivation for the people that, okay, if there is a huge amount of data where all these tasks are given, then uh, any model for zero with zero shot should be able to provide such kind of outputs. And then they, in the twice setup, try to do the same thing, and they got good results in the beginning. So the training data set that they were targeting was common crawl, but they found out that the common crawl was not pre-processed correctly, and it has many content that was unintelligible. So they have to redo the whole process of like creating their own data set, which they are calling as a web text. So how did they do is they did the filtering of like Reddit, for example. So they took out all the content from the Reddit, and then they only kept in the web text those content which had got like more than three karma, which is like more than three likes. So if it was liked by more than people, so they said, "Oh, okay, this should be a good text," and then they considered only such kind of text. So the resulting data set, which they named as web text, contains the text subset of the 14 million links that they had initially taken. So it boils down to like 8 million documents for a total of 40 GB of text. That's a huge text. And another point to note over here is that it's difficult to get results at GPT because these data sets are not openly available, and they have done a lot of pre-processing to prepare those data sets. So in input representation, they are going with something called as byte pair encoding, and byte pair encoding is somewhere in between a byte level encoding and a word level encoding. So in word level encoding, you have got like all the words of the English, and in byte means you are representing each character. So the limitation of the byte pair is that you don't get the meaning of the word because the characters don't mean anything, right? And the positive is that it reduces your space or vocabulary to a very few things. Like byte pair means 256 characters are allowed, that's it. And if you talk about the words, then there are many words like in the dictionary that you normally have, and then the word limit goes to like 130,000. So they went with a byte pair encoding, which is somewhere in between. So how byte pair works is that it takes single bytes, and then it takes like bigrams, like 2 bytes at a time, then 3 bytes at a time, and starts calculating the frequency. So whichever is more frequent goes into the dictionary, and that's how they create the dictionary out of it. So this is like best of both the worlds. It reduces the vocabulary size, and also has a lot of identifiable words that make sense. And this becomes like the basic for their encoding mechanism. And in the architecture of the GPT-1 also, they made some changes because they introduced the layer normalization, and in the beginning and the end of the steps. And so if they are introducing layer normalization, which means that they are stabilizing the inputs and also the outputs coming out, going to the another activation function or something, they are like normalizing at each level. So there is no exploding gradients kind of problem existing. So they added this layer normalization, and they also scale the weights of the residual layers by a factor of 1 by root n, where n is the number of the residual layers. And they also expanded the context size from 512 to 1024, which basically means that uh, uh, if they were able to process 512 tokens before, now they can process just that twice. So this gives you more context from the background, previous words. So long range dependencies of the words and context association and everything retains, and you can better predict the next word that should be followed. And the vocabulary size is also like expanded to 50,257 with BPE. So now they were interested in finding out how does the zero shot mechanism works on the web text, and this is a good table to represent that. So they have like four models with different parameters, number of parameters. So, and this is SOTA is like state of the art models, and these models are something that have been like fine tuned, and the models that a GPT is training on, these are zero shot. They are not fine tuned for this specific task. So when they look at the Lambda data set, now they find PPL is the perplexity score, ACC is accuracy. Uh, the lower score of PPL means the better model it is. So if you see, as the size of the GPT-2 was increased, the values were getting better. So that means it was performing good on the Lambda data set. And what is Lambda data set? I'll show you with an example. So given any context, Now there is a target statement, and it has to predict the last word. So this is how the model learns that based on whatever pre-training it has, it knows which last word it would be. And as the number of learned parameters were increased, the model was performing really good, and the accuracy also increased significantly over the state of the art. CBT is children book test where given a sentence, the common nouns and other kind of information was supposed to be uh, judged, and GPT-2 achieves a new state-of-the-art result that is 93%, which is very good. Then Wikitext and PTB and all the different data sets were checked, and it was found that GPT was performing fairly well, except for uh, BW, which is 1 billion benchmark data set. And one of the reasons why it doesn't perform very good over here is that likely reasons is mm, uh, that they have some sort of destructive pre-processing where the sentence level shuffling removes all the long range structures. So probably the GPT is not able to capture the context because of this, and therefore it performs fairly bad in the 1BW. Then other the results are pretty good. Vinograd schema challenge. In this challenge is about common sense reasoning. So, given two statements with like one word difference, it has to find out where the ambiguity is and what should be the right replacement of the word. So, I can give you an example of that as well. This is the Vinograd data set, where the city councilman refused the demonstrators a permit because so the two words would come over here, feared or advocated violence. So if the word is feared, then they presumably refers to the city council, and if the word is advocated, it refers to the demonstrators. So there is an ambiguity in it. And then the GPT-2 was checked, how does it perform in like common reasoning, and they found that it improved the SOTA by 7%. So that was good. But in the reading comprehensions, where there was a text given and the questions were asked, and in like summarization, where a huge text was to be summarized, the performance was not that great, but still it was like somewhere okay. It rather drops by 6.4 points than the aggregated matrix when checked on Rogue. And similarly, on the translation task also, it was observed that on the dataset WOMT14, English to French translation, GPT-2 only got a score of 5 blue, which is a very bad score. But if you do a French to English translation, then GPT-2 got a better score. But still, it's not no way close because the best is 33.5 blue score. And in question answering, again, the same thing, GPT answers 4.1% of the questions correctly, which is not good. So GPT-2 was not performing. So it is not like the usable model in general. In generalization versus memorization, here they are basically talking about that they want to study how much is the overlap between the data sets that the model has been trained on and the testing data sets. And then they are trying to get this information that how much has model generalized, or it is just memorized information that the model is splitting out. The idea over here is that in the CFR10, it was reported that 3.3% overlap between the train and test images is there. And if that's the case, then you cannot say that the model is generalized, because if your testing data is already present in the training data, the model could have memorized it. So for that, they wanted to conduct the same study for their web text as well. They created something called as Bloom filters with containing 8 grams of web text training set tokens. And then they did an analysis to find the overlapping. They found a bit of overlapping, which has been reported in this table over here. And you'll see that the overlapping, the maximum goes about 9%, Otherwise, it is fairly low. The average overlap is 3.2%. Somewhat surprising, many data sets have larger overlaps with an average of 5.9% overlap. So there is some overlap. And they also mentioned that they found that this overlap was actually good. Their analysis suggests that overlap between the web training data and the specific evaluation data sets provides a small but consistent benefit to the reported results. And the other trend that they have observed is that as the number of parameters of the model was increasing, there is a constant decline in the perplexity, which means the model is getting better. So over a period of time, in this paper, they have suggested that even the larger models can perform much better than what the current model that they have reported in this paper. And this is actually true because after this GPT-3 and 4 will come out. So their whole research on this suggests that unsupervised task learning is a promising area that they have explored later on, and then which led to the development of other GPT versions and Chat GPT that we have today. They have also concluded over here that GPT-2 is not a usable model as well. And given the prior success of fine-tuning GPT, they are still trying to investigate that how the fine-tuning on benchmarks can actually benefit the capacities of the GPT-2 that it has right now. And that's all the paper talks about. Thank you.